All right. Thanks everybody for coming, and thanks for having us. So this is our first Art into Science. Somehow, though, I know this is a conference for defense and let in some people that are attackers, but we're working on some cool stuff that I think may be relevant to the defense community's interest. And just a little bit about us quickly. We have been partners in crime for the last 10 years or so as penetration testers. And we've seen a lot over those 10 years, and like techniques for performing assessment, techniques for simulating break-ins, either as part of like a red team or like a really in-depth attack. And we also know a lot of the inefficiencies in that process and a lot of the downfalls and ways that it's not valuable or could be better. And so that's what we want to talk to you about today, is we've been working on some new techniques and some new automation to basically like make an Iron Man suit for your testers and for your penetration testers or people that are working on attempting to break in.
Yeah, so the process that we like to think, the way we like to think about this process is, let's take all of the information about a target, an organization. Let's try to identify what their attack perimeter is, and then let's, at scale, try to do vulnerability testing and analysis of their external footprint. Yeah,
and a big piece of this is we realized that we had to do it continuously, or our data set was just always diverging, if we have a team of people working on these assessments together, or just was out of date, like as soon as tomorrow. And especially in cloud-hosted environments where everything's dynamic, we had to really adapt some of our techniques. And so as we started building some tools that could continuously assess both perimeter intelligence and then do a continuous analysis of exposures on that perimeter, we really realized like we had a very powerful tool, and it really opened up a whole new way of thinking, which today I want to talk to you about one feature of that, which is perceptual analysis. We came up with some ways to take screenshots, which if anyone's ever looked at thousands and thousands of screenshots of applications, it's a complete chaos, and it's a really tedious task, but we want to be able to bring order to that chaos and basically sort our screenshots with visual similarity, and then even taking screenshots of attack paths or attacker paths, like, and then being able to sort those has helped us really quickly find some interesting exposures. So real quick, who in here has been a penetration tester or is a penetration tester? Okay, so there's a handful of people. Anyone in here had their network or applications penetration tested? Yeah, pretty much everyone. Has anyone ever, when you were a penetration tester, stolen an AWS secret key? Yeah, okay, see a couple hands. Anyone had their key stolen? Yeah, okay. Anyone ever stolen 64 keys in one night? Put your hand up. All right, he did it. To demonstrate the capabilities of this, we really did want to focus on cloud environments, and this was our target. For those of you that don't know what Elastic Beanstalk is, it is just a really easy to use and efficient orchestration service that Amazon provides. Basically, it's as simple as upload a zip file or push a Git repo with one of these stacks, and now it just works. Now it's just on.
Yeah, we decided to go after this as the demo because we didn't want to target out any individual organization.
So we picked on everybody. Yeah, every major organization or even small, medium businesses are likely hosting something on this, and like as simple as pushing a Docker container. Unfortunately, a lot of the templates that people are using also have baked in mistakes and misconfigurations and vulnerabilities that if the developer didn't know to clean up that mess that they started with, it can be exploited. So let's talk about hacking it. First step that we did was we automated the subdomain discovery. So you can see there that the registered domain in all of these hosts is elasticbeanstalk.com, but there is a wild variety of subdomains that is essentially that's the virtually hosted, or this is the what you would point your CNAME or your A record and your DNS config at, so that this backend application ends up coming through on your site. The IP addresses for these change typically daily. It's just like EC2 in the backend, but like all traditional penetration testing or assessment, vulnerability scanning tools really quickly break down if they only take IP addresses targets or even handling like this large of a list of targets at a single time. So what types of issues are we trying to find? Really aligning these 5 avenues of attack with attack paths that are like common patterns that we see. And these are like the 5 avenues of attack that are typically involved in every breach. At least one of these steps is in the attack chain, or one of these types of exposures. And this is just with our experience, like every story we tell, every report we write has at least one of these as something that could have been mitigated or something that needs to be remediated because it's how we broke in.
Yeah, one of the pieces of the attack chain that we use to get into or compromise a network usually involves one of these 5.
Yeah, and traditional like vulnerability scanning tools, they can check for these types of things, but they always tend to have a signature or need a signature, typically in the form of a regular expression, to be able to weed out false positives. And like there's maybe a team of people at like your Tenables or your Qualises that are like writing these signatures for every CVE that comes out or every piece of threat intelligence. But just a couple of ordinary guys, and we don't have time for that. So we're like, what if we didn't need that? So what type of paths do we use? Shout out to Gray Noise. I know that it's been talked about quite a bit. Andrew spoke here yesterday. He was kind enough to share some data on HTTP paths that his sensors were seeing, and we decided to take that entire list, which was thousands of paths, and fire it at Elastic Beanstalk.
So typically, if you were going to take this data set and fire it at Elastic Beanstalk, you'd run into the problem of custom 404 pages, where some pages that you send a path to don't actually exist, return a status code 200 OK. You have to do very custom logic to try to identify 404 pages, which works when you're targeting a specific target, but it doesn't work when you're targeting 88,000 targets, right? It kind of breaks down at that point. So how do you go from a set of paths without writing specific signatures for them and trying to identify vulnerabilities? And that's kind of the technique that we've been working on.
Yeah, so to break down like the effort to basically simulate in a controlled way the opportunistic attacks, we had about 88,000 targets. We kind of stopped there with the Elastic Beanstalk. Like kind of could go on forever discovering new ones. We took just 10 of the paths to really focus on that we thought would make something interesting would immediately fall out of it. This was over 880,000 requests that we made. 52,000 of those came back with a 200 OK response and some response body that we could take a screenshot of. We then filtered it down to about 4,000 after taking screenshots and throwing out all the ones that had the same visual representation. And that was typically just meant it was a custom 404 page on that endpoint.
The idea behind that is that if you hit like /admin, looking for an admin page, and you hit /changelog.txt, those should never be visually similar. And if they are, then that means they have a custom 404, throw them away. So basically going through, taking screenshots of everything, throwing away any 2 screenshots that look the same on a specific host, throw them out, they're 404s. All the paths that we're requesting should be visually unique.
Yeah, never mind the like months of engineering and research we put into this. Like total time, actually, like once we ran this exercise, was about 30 minutes of analysis. The first path that we focused on was something that is in the default of every Laravel package that is one of the templates a lot of people deploy up to Elastic Beanstalk, and it is a /.env for environment variables file. So we found 321 of those that were valid critical exposures in this exercise, and like these are like the keys that were coming out of them. We're seeing database passwords, we're seeing SMTP passwords, we're seeing pretty much all the important stuff that powers an application and an environment.
Payment processing, Google Analytics information.
Yeah, Facebook tokens, Twitter
AWS
tokens.
credentials, database credentials.
Yeah, so in total, in that like 30 minutes of analysis, and to a path that real attackers are checking for, this is the payday. Like this is what you see. This is what you get. really like, and bots are also scanning, GitHub for these types of files that are checked in, and they're hitting these major cloud providers all the time looking for this information. So how can we like find it first and find and be more efficient at finding it?
And how do you look for something when you don't know what you're looking for, right? So we made these requests. We don't know what the response should look like. A lot of these have different signatures that could have flagged, could have caused false positives or false negatives. By using this visual similarity technique, you're able to identify kind of a range of screenshots that all look visually similar out of the whole data set, which all end up being like, these are all the Git configs because they all look like visually similar, but they're different. And these are all the environment variables, .envs, because they look visually similar but different. But within the spectrum of all the custom 404 pages that were missed because they had an advertisement on it or some other resource, you were able to pare that down to just the interesting findings.
Yeah. So yeah, we also found 9.6 gigs of source code exposed in this exercise.
Just text, not the images part.
Not the images, yeah, just the text. So how would we have done this 10 years ago when we first started? I was telling someone the story the other night of my very first professional pen test where I was being paid to do it. I used Buster. Anyone in here familiar with this tool? Yeah, this was like the OG content discovery technique. Burp has it built in now, and a lot of the modern pen testing tools all have this built in, where there's a lot of other scripts that kind of do this. But this was really rudimentary, multi-threaded Java GUI that you could give it a dictionary of paths you wanted to brute force and one target at a time. Most of the time, it would get you blocked because you were spraying a lot of requests from a single host. If there was any kind of something to detect you, any kind of IDS, IPS, any kind of people watching this massive amount of traffic coming in, like it would get you blocked. We also had the case where
custom 404s would be a big problem, right? You just get a bunch of 200 OKs in there, and most of them are not good.
Yeah. We also had issues with like some of the word lists that had like really offensive words in them. Like customers are complaining, like, why are you making a request to this? And so we ended up like banning this at Bishop Fox, like not allowed to use it anymore. Not worth it because like this is what the denial of service scenario looks like when it's like this is basically a visualization of the access log requests. It just bombards that server.
Yeah, on the left is the IP address, on the right is the server and the different paths. So it's just hundreds of thousands of packets kind of being slammed against the server. And so a lot of times this causes a denial of server problem or denial of service, and the server goes down.
Yeah, so we realized this, like for this technique, we didn't want to do this. We wanted to do better. And typically it would do some fail case testing where it would make a request to like a GUID or UID or like / this definitely does not exist. And then it would try to signature that response, which this is a very effective technique if you're only going after one target that has the same fail case. You can check the content length. You can look at the DOM and like take out inner HTML and just kind of signature the structure of that DOM. Like all CNN pages actually have like the same DOM. They just like fill in different articles and different content. But yeah, this doesn't scale. Like this ultimately doesn't work.
It doesn't work if you're targeting 88,000 targets at that point. All 404s look different. So how do you still manage to remove that data set?
Yeah, and so you can also, like kind of spend the time going to each of the pages and looking at them. But like if you have thousands of like /docker/variables.env to go review, this is a recording of Oscar doing this very slow manual process. You have to
go through each link, click through it, wait for the page to load. You're going to get SSL cert errors. You're going to have to click the okay, yes, I'm sure I want to go check this 8 million times. You have 4,000 of these to check. Like, how do you go through that process?
Yeah, dirty little secret. Like, you may be paying a penetration tester to spend their time doing this. So yeah, that's really like a needle in the haystack. We really
so out of those 4,000, there was a single one that was valid, and so
would have spent hours, days maybe, looking at a total in any kind of large.
And that's
attack
a single
surface.
path, right?
Yeah. So these are really the process problems like we set out to address with this new technique. Like ultimately, if you're working in a team of people, you get like inconsistency. This is actually inconsistently performed because it is a pain in the butt and it's tedious and no one wants to do it. like you get divergence in data sets. Like if you're not using a central repository or database for what's been reviewed already, kind of everyone, or maybe halfway through your assessment, you find another 100 targets that are going to be valid and in scope of what you're looking at. And now, did someone go do this same technique of content discovery or path brute forcing on those? Maybe, maybe not. And it's just really way too inefficient.
And with cloud computing, again, you go do a port scan on a specific set of IPs at the beginning of your engagement. A week later, all of those domains point to new IPs because it's all dynamic. And so now you start attacking servers that just don't belong to the organization that you were initially assessing.
Yeah, so one way to reduce time and labor is to also do like preloading of the screenshots or pre-rendering. And so there's tools like GoWitness, Eyewitness that are commonly used to, like, let's just go out and take a screenshot of all of those, and then it's basically as quick as like, okay, I just like look through all these, and now I'm like, at least like saving that amount of time.
Yeah, so this is the same process as the one we just showed, but with all the screenshots already taken in a directory, and they're all visually sorted by similarity, meaning the very beginning images on the list are basically blank, and the very end images of the list are essentially very visually dense. So these are like things that have very high amount of CSS, very high amount of like image content. Somewhere in between that that range, you'll find like a set that is the vulnerability.
The outliers.
The outliers.
Yeah, and that's like, this technique of the unsorted image was basically state of the art in 2018, but still slow and inefficient for our liking. So how can we take like humans out of this equation? We wanted to see if there was a way to get the same type of critical exposures without writing signatures or having to do some kind of fail case. And then we also wanted to be able to do this at like a massive scale. So like our ultimate goal being make the screenshots that are interesting to look at come to me, like get in front of my eyes as quickly as possible. This is a process we came up with. Step one was really to discover all the subdomains and target like that for our target continuously and automatically. And we'll have there's some OSINT tools, there's some open source OSINT tools that we've contributed to and are using and to accomplish this. We then probe for open services like every day on that targets list to make sure they're still live, still active. Request the paths from multiple IP addresses to avoid getting blocked or to distribute that load as well. And especially if we kind of randomizing this with a bunch of other targets and a bunch of other organizations where really aren't like pounding on any one box at one time. And then capture that screenshot of all the valid responses. And then it's actually some fuzzy hashing. And I'll explain exactly how it works. It's actually pretty straightforward to be able to sort them by visual similarity. And then the outliers, as Oscar mentioned, really become the ones you want to look at. And then we have cool hacks. So for that target discovery, one framework and library that we've integrated with is OWASP Amass. This is like, I think it's over 50 some sources now. Of open source intelligence gathering. It scrapes search engines. It's pulling in from some of the dragnet services like Shodan that are scanning all of IPv4 on a regular basis. And it also has capabilities to do recursive brute forcing of subdomains, as well as pulling in things from like passive DNS sources. And you can build like a really good target set like with this for free. Kind of probably need to get paid for APIs if you want to take it further than what this can do. And it's like a Golang package that's really easy to integrate and has graphs generated from it that I don't really know how to interpret them, but they look cool. So yeah, that's like how we got this list of targets. Anything else you want to talk about that?
Yeah, I mean, 5 times.
Yeah. So the technology stack that we ultimately end up using then is we're using Lambdas to make these requests with headless Chrome, S3 storage to store all the screenshots, Elasticsearch to be able to write queries on the metadata that we save, like the response codes, the content link headers, the anything else in the response that we do want to kind of search for. And then using Recognition, which is AWS's OCR library. It's like a really simple to do a one-line request or one-line curl to and give it an S3 bucket URL for the image, and then it'll OCR all of the content for you.
Yeah, that helps you find things that are just visually difficult to 404 check against.
Yeah.
So they'll say like 404, they'll have a fail whale or not found for some reason. So this is what the traffic looks like from the application. Instead of a single IP on the left, you see there's tons and tons and tons of IPs. This is us running it just against one target, but if you distribute it across 88,000 targets, you get like one request every, minute or so. And
yeah, this like ultimately ends up looking like less traffic than like Googlebot or Bingbot like crawling you. So specifically, how does the perceptual analysis work? Really simple. You reduce the size of the screenshot, reduce the color, go to grayscale, compute the differences in the pixels that are adjacent to each other. So the kind of algorithm, sorry, it's at the bottom of the slide, I don't know if people in the back can see, is basically like if pixel x is less than pixel x plus 1, like assign it a 1 bit, and if otherwise it's a 0 bit. And then you get this nice 64-bit hash that you can convert to like basically ASCII or to represent, and then whenever you sort your images by that hash, like all white space is kind of like all zeros and maybe like an F. And then as there starts to be more gradients in that pixel or in that perceptual representation of that screenshot, you get basically things kind of automatically sort into two categories, almost like white space and then very dense. And that is almost a really easy way to look at a specific organization's perimeter and say, everything on this, this side that's very dense is probably valid consumer facing. It has like the company logo on it. It's, maybe it has ads on it or it has like whatever that company does. And then everything that's mostly white space is probably a misconfiguration, probably shouldn't be on the internet, is maybe for employees or enterprise only, or is
an API or something
an
like
API,
that.
yeah, or it's like maybe it's like just a login page that would be like what an attacker might look at first, and so you kind of automatically get this sorting out of it, which is really useful. Just a little quick, we also loaded in 1,279 federal government domains last week, and you can kind of start to group them, the ones that have the same representation, which is really powerful. So like we might see like, oh, Cisco VPN login, show me all other domains that have that
same screenshot or visually similar screenshot.
And then you can kind of see the perceptual hash is like the P and the 2 and all the 6s, and just show me every other site that has that same content being served up.
Yeah, and you can use it to say like, give me screenshots that are this exact image, or like orders of magnitude, like slightly different from one another. So you can kind of group things that are visually similar together.
Yeah, like say like show me the hashes that are like have like 1 bit difference, or one
Maybe like a timestamp or something on the image that's just small changes that would change the hash just by a small amount. So you can kind of group those all together as well.
Yeah, and then, or say like, let me increase that frequency to like 5, and then you kind of get at things that are just sort of similar. So what's next for this technique? I think this is a prime candidate for also doing some like pulling in the OCR, finding like maybe it's an image of like a sign up button. And now we can easily find all open registration pages that an organization has facing the internet, and really like write something to take the text out of the OCR blob that recognition sends back. It could also be to even weed out further false positives. Maybe there's some more complex dynamic 404 pages, but it still always says the same thing somewhere, and we can pull that out of the OCR. Also a prime candidate for machine learning. Any problem that just a human can quickly look at something and say like, yeah, yes or no, to whatever question is being asked, like, is this vulnerable? Is this something I need to follow up on? Like, that's something you can train a machine pretty easy to do. And we also think—
Yeah, there's something that happens when you're looking through large sets of screenshots. As someone that's done this for a long time, you end up like clicking through and you're like, uh-oh, I know this is going to be vulnerable just by looking at it. It's either it looks like it was built in 1997, or it looks like there's a problem just by seeing it. And so I think that, again, if we can teach ourselves to do that consistently, and if a bunch of us can do it consistently, then we can teach a machine to do it.
Yeah, and I think that we're both doing the like Stanford Coursera machine learning course and struggling with our linear algebra problems right now, but the unsupervised machine learning techniques where it's just like, here's a ton of data, you figure out how to make sense of it, and where it can potentially, like if they can do this to find cancer with MRI images, I think like we can maybe get these screenshots categorized into groups that like we didn't even think of yet. We were kind of thinking about the a hot dog or not hot dog, like is this is this like valid consumer facing or shouldn't be on the internet, or like there might be 6 categories in that data that we just haven't thought of yet. And then I think just the notion of being able to collaboratively filter and like review this with our peers and say like, yes, like let's click yes or no, like this is something that I wouldn't want on my perimeter, and we like work together to put it in one of those 2 categories is also a really powerful logical next step with this. And I think that's all we got to share. Any questions? Yes. They have not bothered us. I'm kind of like, it was kind of a stop hitting yourself, Amazon, because we used Lambda to attack Elastic Beanstalk, but no questions asked, because I ultimately think we are like, we're less traffic than a crawler. Like we kind of just took, yeah, yes, it was like 250 million requests, but it wasn't like all at once, and it wasn't, it's kind of not all on the same even data center. Like some of those were like EU, and some of them were US West, and some were US East. I mean, maybe they noticed it, but they didn't say anything. They could tell where it's coming from. Yeah. Yeah, I'm familiar with that, but I think we violated the terms of service, and no one called us yet. This is a really good question as well. I guess like I don't know if like the mechanical Turk would have to have like the I guess some instruction, and a lot of times whenever we're doing like these paths from gray noise, I had no idea what it was going to look like on the other end. Like we would sometimes do some Google dorking to find a similar exposure. If it's like commercial off-the-shelf software, we try to find that, and sometimes that's a way to get an idea. But most of the time, it was like I have no idea what's going to be on the other end of this, so I don't know how to train someone even of what to look for, other than
we know they'll group together.
Yeah, we'll know if we do perceptual analysis, they'll all kind of all the ones that are 404 pages will go to this side, and the outliers will be interesting. Question? I'm going to write that down and research that. Thank you. Oh, awesome. Let's talk. Any other questions? Yes. Yeah, that like, and there are different types of. So the question was, why did you reduce color from the screenshot? There are different types of perceptual hashing, and like this is actually commonly used technique for like fingerprinting audio files or video files or images, and some don't do that. This is like one of the most simple hashing algorithms, and it was working. So I don't have any other reason other than like we tried it and it worked, and some of the other ones are a little bit more complex, but probably didn't need those for our use case.
Or maybe we do.
Or maybe we do, yeah.
Yet to explore. Yeah. So one of the things that we started doing on after doing that initial like fuzzy hashing was doing kind of average color of the page as well as a secondary grouping. So everything that has a visually similar would group together, and then within that group, you'd also kind of have average image color.
Yes. Yeah, so in that example that we did with Elastic Beanstalk, I'd say like the review time was down to about 30 minutes of like, these are all the outliers that fell out, but if we weren't using this technique,
I wouldn't even try.
We would have given up.
Yeah, so there were, out of only the 10 paths that we checked, it generated 54,000 images. And so to review those 54,000 images, we're just like, yeah. I mean, it's not.
When there's the first time we even did this sorting, like we focused on a very specific organization, and there was only 3,000 even just screenshots up to the root path to review, and that took me about 30 minutes as well, just to
hot dog, not hot dog.
Just to like put them in a different folder, depending on if it was a valid site that had the company logo, or if it was something that I was like, we should look at this more and try to pack into it. Yes. So like that's our day job is basically like doing very like in-depth penetration testing on like given a target, and in this case, that would be like the next thing in our workflow is all these ones that look dangerous, shouldn't be maybe on the internet. Like let's go manually investigate them, and that is something like we may spend hours or days on it on a given target, reviewing it with other tools and techniques, and kind of going through our typical methodologies. But
yeah, for this demo, it was just we didn't do any further investigation of those credentials as part of, if we were doing this for an organization as part of a pen test, we'd go load in all those databases, load in all those AWS keys, and find out what the impact was.
This ultimately just makes it faster to impact is how we're looking at it. Yes.
Yeah, so the question was, do we retain the OCR index information? And the answer is yes. We kind of group all the images. They have JSON files or JSON blobs associated with them, and we like merge in the OCR information. So you can basically search, like, give me every page, every screenshot that has the word login in it. OCR is great, but it's also far from perfect. And so you get some weird words in there, and like some things you're like, what? Yeah, so it's interesting, and it's good to find like very specific words. But if you try to like search for a sentence that might be in a page, very low likelihood of success.
It's a good question. For like domains and targeting, we've just been handling Punycode conversions to be able to target them. When it comes to like some of the screenshots, even there was like some Taiwanese stuff. There was
So one of the things about the data set that we're looking against, a lot of them are very specific pages for very specific frameworks on, here's this /changelog, and that will be coming from a package and most likely won't be in a bunch of different languages. You might get like custom 404 pages that do have different languages, or if you're just doing the hot dog, not hot dog thing on the root directory, you might have that. But the types of paths that we're looking for don't lend themselves to that.
Especially with like the commercial off-the-shelf software, it's kind of easy to represent. And then the nice thing is with the paths that like we could take from like honeypot analysis or from like gray noise is like real attackers are searching for this. We're just going to be focusing on the outliers no matter what it is, and we can kind of manually put it through Google Translate or something if we need to, if it's interesting. Yeah, that's something that we haven't really done. I think like threat intelligence is something that's very new to us, kind of learning a lot more about that from talking to some nice people here. And I think that, we have seen things where like we find phishing kits and then like down in some directory is like the calling card of like, hey, if you want to buy this phishing kit from me, like contact me here on Twitter or like. Coming in a couple months, we're going to be doing a presentation where we actually are taking all the domain permutations and all of the bit flips and all of the typo squats and everything, and then putting that some major brands through that, or like you can do it for really any organization. And then you see, like I have Office265.com has the phishing login for sure, which I think is really interesting from a perceptual analysis. We could apply this technique, just as you said, to say like if we see the same hash as Office 365 login image on any other domain, red flag that.
That's the last question.
Cool. Thanks, everyone.